So solving should be pretty simple for this. We're going to divide by 3 on the first one to get that x is less than or equal to 3. Or, and for this one, we would divide by negative 2. And if we divide by a negative, we will have to flip this. So x is now greater than negative 2. But if you stop to think about this statement just as common sense, it's a little bit strange. So before you even graph it, if you think about what it means, x is any number that is smaller than 3 or equal to it. So think of any number that is smaller than 3 or is bigger than negative 2. Well, if you stop to think about this, pick any random number. Anything. Pick anything. Keep it to yourself. Pick any random number. Ask yourself this question. Is the number that you're thinking of smaller than or equal to negative 3? Or, if it's not that, is it bigger than negative 2? Raise your hand if your number did fit one of those two descriptions. I'm very concerned about the fact that some people's hands didn't go up. Here's why I'm a little concerned that people didn't find a number that did that. Every single number works. And when we go to graph this is when we see why that's the case. So if we graph this, go ahead and make a number line. So there's 0. Negative 2 would be somewhere right around here. Positive 3, a little bit further off to the right. And when you go to start building this graph, you will find something happening that does not normally happen. Let's start with this one. Less than or equal to 3. Solid or empty?
Solid.
Should be a solid dot. And remember, because it says or in the middle, we are going to graph these two things completely separate. So we're going to graph this first one as if the other thing is not even there, and then we'll do the other one. Should this arrow point left or right? It should go to the left. Everything smaller than 3 is over here. And I do want you to extend it all the way to the end of the number line you drew, because it does cover every number. But now that we've done that, let's pretend that that's not there and go do the other graph. So, as if this had not even been written there, x is greater than negative 2. So here's negative 2. Should this be solid or empty? It should be empty. So up here at negative 2, I have an empty circle. Greater than negative 2. Should this point to the left or the right? This one should point to the right. All the numbers bigger than negative 2 are over here. But look at what happened. Because of the word or, when I drew each of the arrows, together they overlap and cover absolutely everything. Because absolutely everything was covered, the graph should actually be redrawn to not look so messy. There's 0, there's negative 2, there's 3. And really what we see here, because they've overlapped and they are now covering every single number on the number line, our graph is the entire number line. And there is a specific response to this situation. Last chapter we saw weird responses like no solution and infinitely many solutions. For this, in an inequality, there is no such answer as infinitely many solutions. Because technically, every inequality has infinitely many solutions. Any inequality you solve, there's an infinite number of numbers that you could say are a solution. When you consider all the decimals and all the fractions and pointing in whichever direction, there's always an infinite number of possibilities. But for this, it's a specific response beyond just saying there are infinitely many solutions. Not only is there an infinite number of solutions you can choose from, but there is absolutely no restriction to the numbers you choose. It is all real numbers. This is the response that you would be expected to have if every single number on the number line is a correct solution to something. All real numbers is the solution and response that we would be looking for.